Hello, everybody. I'm very happy to be here today together with Stefan Methogo, and we are discussing about our new Melsoft Vixio software. It's a visual inspection software, and we have a very casual chat here. My name is Daniel Sperlich, and I'm product manager for the factory automation in Mitsubishi Electric, responsible for the PLC.
Thank you, Daniel. I'm also happy to be here. My name is Stefan. I'm responsible for EV and lithium-ion batteries at Mitsubishi Electric. I'm very happy to be here also to share, the experience from the automotive industry on how this unique solution can be applied to the automotive challenges. So very glad to be here. Yeah.
I think that's going to be very interesting because the origin of that software or the development of that software was a little bit different. So it was for the electronic market. So in Fukuyama Works, that's in Japan, over there they had the requirement that for the manual inspection especially, and the big variety of options that they have for their breakers, they needed to make sure that accuracy and quality inspection was always at the same constant level. And they could, or they found out that with AI now available, they could reduce very much the defects and also increase the time, basically, that is required for every inspector that is required for each product. Mm. And that for the electronic market. And I think today it's very interesting to have also another glance, basically, from the automotive market. Thanks for coming.
Yeah, that's right. And I think that you're good to mention it because, we're not only providing or selling product to customers, we also have our own factories. So basically it means that we also have to improve our own operations. So basically every solution that we're releasing to the market has to be kind of tested or also applied to our own operations before releasing it to the general market, basically.
Talking about visual inspection. Of course, in every company, you are very keen to keep a high quality for your products. Because if you buy a product by yourself, may it be in the supermarket or any electronic stores, you expect it to be very long lasting and also highest quality. I think you would reject immediately some TV screen that has some defect pixels or something like that. And the same challenge also we were facing, as I said before already, in our own factories. So we wanted to make sure that especially also this, let's say, this process is as simple as possible. So when talking about visual inspection, I believe that not only in Japan, but also other regions in Europe, it's very hard to find kind of motivated people who do this inspection task. Especially if you think about it, you have to do it also for like 8-hour shifts and something like this. And this is very, very tricky, I believe. So with Melsoft Vixio especially, this is one point that we want to tackle. So we remove, let's say, this burden for the inspectors to always make this tiring task. And on the same time, we are also trying to help companies with the labor shortage. But again, maybe this is a little bit from the electronic manufacturing point of view, but how is it in automotive? Do you also face some challenges similarly there?
Yeah. I think that at the end, it's a general concern because as you also mentioned, we are actually seeing a turnover, having experienced engineers or technicians or operators in the factories that used to actually tell what is a defect only by looking at the product. And this level of knowledge is sort of difficult to transfer to the new generation. So there is a skill gap that we see in the factories. And then, this is directly related to the labor shortages that you were mentioning before. I think that AI vision being one of the, let's say, most mature use case, applications of AI in the industry is actually then a perfect fit because one, we can kind of automate the knowledge or basically the experience that the old engineers or the people that are going to retire, used to have, transfer that knowledge to the AI so that then the AI could actually kind of teach the newcomers into what is a good or what is not a good product, but at the same time kind of compensate the skill gap or the loss of experience that is leaving the company when the people are retiring. So I think that that's one of the things that we actually see in the industry as well. And another thing is that, as you mentioned, there are some tasks that are today not really fulfilling, I would say. So it's not fun to have to sit here like for the whole day inspecting only like hundreds of parts. So I think that at the end of the day, we're also kind of contributing to making the industry more attractive because we are digitalizing, we are kind of, putting AI, which is kind of trendy also and appropriate for the new generation of digital natives. I think that this is kind of adding value to the operation and adding attractiveness to basically the industrial activities. Yeah.
I also believe that Melsoft Vixio can help the companies to, let's say, having some worker, of course, still inspecting some parts, but then not having to focus on the whole inspection process, but only the bad parts, let's say, that covers maybe just a partial, like a few hours during the work time. The other time, they can focus more on other productive tasks. And I also think that, as you mentioned as well, the point that the experienced workers, they maybe have, let's say, again, if you go to maybe automotive, they have to inspect like a very complex bodywork, for example, which has a lot of different parts that have to be inspected. Maybe they can do it within like 10, 20 seconds or something like this. And now, think about it, there's the new guy coming. And of course, like within like the first maybe half year or so, they are not even at that performance level, right? Or maybe even missing some parts. So that's like creating some unevenness as well, like in the inspection process. So I believe also there's a lot of parts being graded as okay parts that are just not thoroughly inspected then at the end. And this is where AI really shines and has a big advantage, because you always have the same level of inspection quality. So no matter if it's the young guy, the experienced guy, whether it's the first hour of the shift, whether it's the 8 hour or the last hour of the shift, it's always the same quality. And I think that's something that especially automotive also is keen on building on this level.
Yeah, I would say that there are two aspects, I think that are also quite important to mention. As you pointed out, I think that consistency in the quality is key. I mean, I can tell a concrete experience that I've had with, let's say, which was confirmed across many customers in the automotive industry, which actually shared that every, let's say, summer season, basically when they have the rotation between the employees that have like short-term contracts. So when they have newcomers coming in the field, they actually see a rise in the defect rate in the factory, because there is a transition time before all these guys can get to the knowledge level where they can actually tell efficiently which part is good or which part is not good. So I think that keeping or automating these, let's say, activities with AI is then, fulfilling the, let's say, consistency criteria. And then the other thing that, it's worth also mentioning is really the operational efficiency, because we see that all the value chain in automotive is like facing heavy cost pressure. We have competition from China, particularly, which is to some extent could be unfair to the European, let's say, value chain. I think that here they need to think of new ways to provide like operational excellence, reduce the cost, increase the productivity. So therefore, automating or increasing the level of automation as much as possible. So it's not only about keeping the quality consistent, it's also about what is the impact that we can bring into reducing the cycle time, speeding up the production line, increasing productivity, which is at the end of the day, what matters for them.
Yeah, you're right. I mean, if every inspected product just takes half of the time, you can have double the throughput.
Yeah, exactly.
And at the same time, you still have the confidence that only the bad parts will be rejected and you can rework them.
Perfect. Exactly. I mean, they don't need even to invest into new lines, basically, by implementing the small improvements into the key stations. As you mentioned, instead of checking systematically all the parts, but giving the hint to check basically the not okay parts, they can fix it. And then it's also reducing then the time that the operators are spending. So, fastening or let's say speeding up the production lines, more throughput, more yields, and then better quality in the end. Yeah.
And I think with the reworking process, for example, you have this nice heat map where you immediately see which area needs, for example, some rework or what is the defect. So you can double check, is it really the defect or can you pass it through?
Exactly.
Great.
Exactly.
Perfect.
Yeah.
And another challenge is also the over-detection in regards to traditional rule-based visual inspection. So if you see the traditional rule-based inspection, you have your part, you have your measurements, your radius, and so on and so forth. But I believe also in automotive, there is like a big variety of parts. I know it almost every year. There's a facelift coming out for some models. So there's a slight change in the bodyworks. There's a slight change maybe in the infotainment system and so on. So I think there's many hundred parts that they will never show us, but they are behind the hood that are changed. And traditionally, you need to create a huge list of rules to detect whether it's a good or bad system. And especially if there is a change or variation in the production, even if it's a very slight one, but still in a tolerance, you also have to include it into your rules. So having somebody who takes care of all this inspection system is necessary. And this is not necessary anymore. So you don't need any specific person or so that creates all these kinds of rules. But instead, I believe in automotive, there's lots of sample pictures of good products since quality in automotive is very high.
I mean, that's a very good point. I think that we need actually to distinguish both use cases. I mean, both the AI creation and then the rule-based diagnosis. I think that, let's start from the second. I mean, one concrete example is that, again, we need to ensure the consistency in the overall process. So making sure that every single part has the same material properties when it comes to the size, the shape, the space also between components. I mean, there is one good example I have for powertrain, where basically they're also checking the size of all the, let's say, assembly holes, because, if basically the hole is bigger, it will actually affect the leakage capabilities of your engine. So basically they need to be sure that every single part that is going out of the factory is keeping or meeting the standards, because otherwise at the end of the day, the defects are going into the cars going to, be used by citizens, and therefore all the recalls or unfortunately even accidents that could happen due to, let's say, the small defects that could have like a big impact at the end of the day. I remember an example from, let's say, a company that used to manufacture also bumpers. I mean, they had like a huge recall in North America I think it was with a German OEM in North America. And back then, the bumper started to fly away from the car because, I mean, there was something going wrong with the mounting or the assembly of all the parts. So basically, at the end of the day, the final user, meaning the car maker, kind of, let's say, canceled the whole contract or the whole campaign due to this basically defective batch. So basically, it can have huge consequences. So therefore, I mean, coming back to what we mentioned before, a rule-based monitoring or diagnosis is crucial. And then you have applications of AI when the, let's say, analysis has to require more variability, more parameters. I mean, and this is where Vixio is actually constituting a big tool, a helpful tool, because we can then address a large diversity of applications. I mean, we're working with steering wheel manufacturers, where basically these guys are even checking how are the stitches in the steering wheel, because, when you're buying a car, you don't want to see a defect appearing into your wheel. So basically, all these aspects, so it can be like up to whatever the customer is imagining. So basically, this is the idea of being versatile and to be able to address powertrain, address stamping, welding, or even then, aesthetics, or basically what you or me are seeing in the car, like in the uplift when we get inside the car, basically.
I think also one of the big advantages of AI visual inspection is that even if you have some defect that you never saw before, it will still be detected, right? So for example, with the stitching, maybe there's a wrong stitch that you didn't expect before, or maybe there's a defect in the leather or something like this. With rule-based, of course, you have to somehow teach like what each defect could look like. But with AI, you just simply give all the good pictures, teach, okay, what are the good products, what are the tolerances, and so on and so forth, and that's it. So you can basically detect anything that is outside the norm and don't even have to, let's say, reteach or something like this.
I mean, we should be as agnostic as possible, because in real life applications, you don't know in advance what kind of defect you're going to get in the production line. So basically, this is the key, to be able to build a system intelligent enough to learn from the existing pictures, existing good examples, and be able to tell apart what is good or what is not good when confronted to any new situation on the line. Yeah.
And probably also it would be too much time consuming if you think about all the possibilities, and especially, as you know, like you always forget something.
Yeah.
So that's for sure. You cannot prepare for every eventuality.
Yeah.
Yes, and here AI shines really.
Yeah, exactly.
So now we know that AI visual inspection is very rigid when it comes to, for example, variations of products. But I think also something, and we mentioned it in the beginning when talking about labor shortages. So having some, maybe this is not such a big topic for automotive, but having some AI specialist or some dedicated programmer that cares about or takes care about all these different rule-based inspections, all the visual inspections. It's also very, very costly to have somebody. So Melsoft Vixio is a tool also that is aiming for everybody to be used. So it must be very easy, and you don't need any, let's say, education in programming or education in data analysis or something like this. So the process of creating the AI is very easy. So what do? You just take a bunch of good pictures, probably directly from the production line, all good pictures. What you do next is you take these pictures and create the AI model. Everything is in the browser, so everybody who uses a PC at home is already used it.
Yeah.
And with just a few clicks, you created your first AI. And with the no-code or low-code solution, you can then create your task. How should it be set up in your line? For example, this is my connection to the PC, this is my camera, and what to do when the product is good, what to do when the product is bad.
Yeah.
You deploy it on the machine and you're ready to go. And this is something that doesn't take very long.
Yeah. I mean, I think that at the end of the day, it all comes down to, I would say, competitivity, scalability, accessibility. I mean, competitivity, why? Because as I mentioned before, all the automotive value chain is facing cost pressure. So basically they have to change the way their operations have been running and change the way they have been also engineering. So basically having a software which doesn't require the same engineering effort or does require a small engineering effort, that's contributing already to the competitivity from R&D even to the operations. Then accessibility. So basically here, I mean, what we actually see as an obstacle, I mean, I've been talking to a lot of digital manufacturing executives in the automotive industry, and they all shared something common, which is the fact that, you know, AI is not really accessible. So usually you have in the tech centers or the R&D centers, a group of AI experts that are developing AI models at group scale. But then the reality is different because at the end of the day, every factory is unique. So you cannot have any universal AI. So at the end of the day, we need to give, let's say, the tools that can be adapted to the local factory circumstances. So, and then local factories where you might not have the skills or the resources to actually, you know, develop the AI models locally. So having a tool that is accessible enough to be, you know, used by experts or novices. I mean, I'm also using it myself, so I mean, I'm not like from the field. Is actually helping in that. Is actually contributing to the accessibility. And then last but not the least, scalability, which is clearly related then to the previous point, because I mean, one of the obstacles with AI in the industry has been scalability. How to move like one measure or one way of doing from one plant to the other. And I believe that by being like competitive, by being accessible, then we can easily scale and then deploy the same use cases, deploy the improvement measures, not only in one plant, but also at global corporations that have like 200 facilities worldwide.
Yeah.
So,
I think also worth mentioning is that when you design a new part, let's say, it just takes a few minutes until your AI is ready to use. So you can deploy it then in a few minutes into your production line, and then you're ready to go. You can already start production, have your quality inspection in place. Yeah. And I think that especially also accelerates your time to market then at the end. Just imagine you have to take like many hours or something like this. but instead you could just go for a cup of coffee, come back, and everything is running.
Yeah, I mean, that's a very good point. I think this is a real use case. I mean, this is real life. And typically what we see in the investment profile in the automotive industry is that, when they're investing in assets, in new production lines, this is huge investment, which they get the return on basically over like almost a decade. So basically the same asset has to be used in the factory for a decade or even more. And then as you pointed out before, there is uplifting. So every year, 2 years, 3 years, it's getting shorter and shorter. The car makers are, changing the design, adding new diversity, new colors, because, it has to be customized also by you guys, by the citizens. I mean, everybody, would like to get like a personalized color or, screen size or whatever in the car. So customization, diversification, which is actually also then challenging the existing production lines, because the same production line has now to handle like different like paint colors, different like steering wheel colors, different materials. So it means that you have to be able to teach new product diversity faster.
Yeah.
So here, this is exactly how we can contribute to this aspect from the original program management, time to market, and even in the asset life, how we can also like shorten the time to market of the new diversities that will be added.
Just imagine over this lifetime of 10 years or something like this, how many variants you will have.
Yeah, exactly.
And every time, if you just have to wait for a cup of coffee or just for 5 minutes, that's a huge win at the end, right? And
exactly.
I think it's also very easy to calculate ROI on this case.
Yes, exactly, precisely. Yeah.
Especially when talking about automotive. So the automation level is already very high and quality standards is also very, very high.
Yeah.
So I believe it could be quite difficult to find some defective products at first, right? But very easy to find the good products.
Yeah.
So for making the AI at the end, we just need the good products. So we gather a few samples, take the pictures, make the AI, and we're good to go. So I think this is also like a big advantage, that you don't have to wait, you don't have to start collecting like the bad examples. It's good for testing then your AI, but you don't need it for creating your AI and have already the reliable source.
Yeah, I mean, that is correct, because at the end of the day, as you mentioned, these guys are selling cars already. So basically these guys are, already selling cars. So it means that the level of safety and quality, as you mentioned, is already quite high. So we're focusing on the small additional percents that are making a significant difference. So here, the difficulty or the other side of the coin is that when you get into this AI implementation phase, typically the common obstacle is that you don't have like samples with bad products, because the production quality is high. So you get much more, let's say, good samples rather than bad samples. So either then, as you mentioned, you wait for months to get consistent bad samples to teach your AI, or you start from the existing. And this is exactly how Vixio is working, and I mean, in contributing to that particular challenge, because then we can start from, let's say, small data set with good samples, and then from then learn, create the AI model that can be right away deployed on the production line. And I mean, as usual in AI, it's not static. It's always going to be improved, because the more we have cases, the more we have samples, the better the AI is going to get. So at the end of the day, we can kind of remove this obstacle or this barrier into the implementation by starting from the good pictures, creating the first models, deploying these models in the production lines. And then the more we get situations or new variability, then the more accurate the AI is also going to get. But from my experience and from the applications that we've been working on, working with data sets with like 50, 80, 100 pictures, we could already get AI performance getting to 100% anomaly detection. So basically,
Incredible.
This is one of the prowess of Vixio, being able to provide a very accurate or powerful AI with a small batch of, initial pictures. Yeah.
So I can expect that most of the automotive manufacturers, they already have picture sets available.
Yes.
Or if not, I mean, the AI inspection is not interfering with production.
Yeah.
So you can just place it somewhere overhead, inspecting the production or the parts, and not interfering with the production cycle. But you're gathering more and more pictures that you can then utilize. And as you said, maybe after having 50 pictures of good products, we can already determine and make a very nice AI model with a high accuracy that is required.
And the other thing is, I mean, as you pointed out, without interfering with the existing production line means that we're also flexible, whether it is for greenfield application or even brownfield, because it doesn't have to be installed only on new production lines. We can already work on existing production lines and improve it without having to change the existing setup by just, being here on top of what is existing, providing the continuous improvement.
So now the AI model is running. We're detecting the good, the bad products, but also, and they're coming back to accessibility. So what about the operators? And what about maintenance, let's say, or seeing some trends? I think this is also a very important part, because at the end, of course, we all have our tolerances. So where we decide, it's kind of still a good product. It's on the edge, but we still allow it. It's good for the next production step. But when we see a slightly trend regarding like product quality, there's always room to counteract in advance, doing some kind of predictive maintenance already, basically. So we are seeing the trend, and we react before we are producing like a batch of bad products. And especially, I think it is important for any operator to easily grasp these trends. And here also, we are having in our browser like a very nice diagram where you see the history of all the inspected parts, you see the trends, and therefore, even the operator level can already, for example, counteract by themselves if they know how to adjust the machine properly. Or all the information is, of course, also accessible in the office. So there, if the maintenance team or the experts of the machine are sitting, they can look at the trends or make their own, let's say, thresholds when they want to be warned.
I mean, as you pointed out, let's say, process drift is one of the, let's say, danger in the industry. I mean, I feel like we've been talking about quality, but keeping quality consistent, and monitoring actually how the quality is evolving. It's one thing that the typically plant managers, industrial stakeholders are sensitive to, because the evolution of quality is telling a lot about your process. If your quality is evolving in a bad trend, basically it means that you have a process drift or something is going on with your process, probably with the new materials that you're using, like with the machine's behavior eventually. So by actually looking at traceability and like keeping track of the quality evolution is one of the, let's say, typical metrics that basically all factories are looking at.
Yes.
And here, I would say that a typical example is in the automotive industry, molding machines. In injection molding machines, they are handling plastic, shaping plastic. Plastic is everywhere in the cars. It's like your bumper, it's going to be your dashboard, your side panel. So it's everywhere. And then, you can just imagine it is in every single car. And then you see the whole car production volume worldwide. So it means that there are thousands and thousands of parts getting out of molding machines every day. So basically here, looking at how the quality of the parts out of the molding machines is staying consistent or kind of getting deteriorating. I mean, it's actually telling you a lot about your molding recipe, your molding parameters, because you know that if you have the same parameters, and all the parameters are good, your quality is always going to be good at the end. And then if you see something going wrong at the final quality, then probably there is a change in one of the parameters, inside the machine. And this is actually one of the conclusions that can be derivated from looking at how quality is evolving. And traceability is also, let's say, used and addressed in that way in the automotive plants.
Yeah, I can imagine, especially, for example, keeping at the molding example. Yeah. There's ways where maybe, let's say, data-driven quality inspection is very helpful. For example, when we look at the data like pressures, temperatures, and so on and so forth, there you can predict already the quality level. Yeah. You can use our MyLab software, for example, with it. But then there's also the other defects where you can only visually really detect it. For example, it could result from some dirt or some blocked passage, of course, in the mold. That results then at the bad product. And I think like a good combination here between data-driven inspection and also visual inspection, I think it's maybe the golden path.
Yeah. At the end of the day, there is not one solution only. It's like multiple solutions. So that's why AI is definitely one of the key. And as I mentioned, there are so much parameters also to handle that we need to have the proper tools to address the visible parameters as well as the non-visible parameters, which is why, there is not only one answer. It's like multiple answers that has to be crossed so that the customers can take the right decisions in the end.
Yes. And I think then also after that, of course, you have to have the traceability or reporting, how your products were judged. Because I can imagine, as your example before, when there's a recall of many cars, you try to find out where was the, let's say, the source of that error. Was it at the manufacturing, at the tier one supplier, or somewhere else? And having like the traceability, the report of all the batches in terms of your picture, the AI result, and also then the data-driven result is a very important part here as well.
Yeah, I mean, reporting is key across the whole chain. I mean, at the end of the chain, you have the automotive, the car makers, the OEMs, that are really periodically auditing the part suppliers to be sure that, the quality of the batches that they are buying is consistent. I mean, at the end of the day, the whole chain has to keep data about let's say, all the products that were manufactured so that in case of any defects or failure found at the end of the chain, we can always go back to the manufacturing batch or the process parameters even at the time the product was manufactured. So that's why keeping consistent reporting capability is actually quite helpful because when something happens at the end of the day, you can actually also project yourself to understand, is it only one product or is it a whole batch? And if you don't have all this data available at end, it's pretty difficult then to judge. And one particular example also is basically the EV industry, where, we have the battery cells module and pack. And now, all the, let's say, communities, not only Europe, are working towards the battery passports so that basically we can track from materials to cell manufacturing, assembly, module and pack, what was the life of all, let's say, the products that are released into the market. So it means that the whole chain, again, from materials, manufacturing, assembly, mounting in the car, needs to keep consistent reporting. So that's why having a software tool like Vixio that is also addressing both traceability and reporting is actually also supporting our customers in this challenge.
So as a conclusion for today, I would say that AI visual inspection definitely helps you with accuracy, especially when looking at manual inspection processes that you then switch over to AI inspection processes, as well as this labor shortage topic where you have the difficulties to find, let's say, the skilled workers as well, and the throughput. So AI inspection process is way faster than the human eye can be.
Yes, definitely. I would say that also to kind of conclude, I would say that the major key takeaways will be, I think, that contributing to operational excellence by reducing the cost of operations, cost of running the lights, reducing the cost of engineering, because again, having a software that contributes to the time to market, contributing to the quality, because keeping it consistent, getting then the final percents, as I mentioned before. So those are the key, to actually support the automotive players into these huge transformations that is required to face the competition and also to bring, let's say, affordable mobility to all the citizens. Yeah, so cost reduction, operational excellence, quality, productivity, and contributing to the transformation of the automotive industry. And I would say that this is what I wanted to share as insight from my automotive experience to this discussion.
Thank you very much, Stefan.
And thank you.
Thank you very much for watching.
Thank you very much.